All right, let's now talk about stuff. And quick reminder, for your written test number 1, the marks has been released last Friday. And if you have any concern about the questions or answer, just visit my office hour, either the Zoom or in person, or just make an appointment with me. We can talk about the question or answer if you wish. For your programming test number 1, it will happen tomorrow. There has been a guide, just in case you haven't read it yet. Right? It's really important. Well, of course, you got to try the practice test if you wish. At the same time, you should really understand the policy and protocol for the test. If you go under around lecture 5, around over here, you can see the guide to the programming test 1. Open the PDF and take a look. You will see everything you need to know. And for tomorrow, as usual, please just wait outside, and we'll let you enter the room as soon as we are ready. We'll definitely start in time. If not, we'll give you extra time, so don't worry. Okay, and also in the guide, I talk about how you can run a mock-up test for yourself. I would say definitely try the Eclipse on the remote labs. That one is going to be the same as what you're going to experience tomorrow, which shouldn't be too different from your Eclipse, from your computer, but it's good to try. Okay, at least try some, develop some code, run some tests, and import and export. Lab number 2, I'm going to release it shortly after your programming test 1, so you got still more than 2 weeks to complete it. Lab number 1 is going to be very interesting, at the same time a little bit challenging. So I think it'll be nice for your learning. So you can look forward to it. All right, any questions about anything before we move on? Everybody's good? Okay. All right, so today the plan, I want to continue to talk about exceptions, right? I'm hoping that I can finish that today, we'll see. And last time, if you remember what we did the simple example, but you actually talk about 3 different versions about how you may handle exception by following this catch or specify requirements, right? That's the main thing to really remember. And I assume everybody's okay with that. If you're not, please catch up. It will be very important for your understanding. For today, I'm gonna do some warm-up together with you just to revisit the circle and the bank example. There will be something slightly more challenging to understand for those 2 examples if we want to add in exceptions. We'll do that first, and then I'll do maybe a couple of more examples, and then I'll move on to a new lecture. And the new lecture will be about how to use JUnit test. But for today, I wouldn't touch JUnit test just yet. I want to do a little bit console testing. But it's going to also include the handling of exception. That one is going to be confusing and tricky to understand. But I will go as clear as possible. Of course, you can always watch the recording. That'll be the plan for today. All right? And then after Wednesday, we go on for the reading week. I will suggest maybe some items for you if you want to catch up during the reading week. Okay? All right. Quick review about the catch or specify requirements. Basically, every time if a method you're calling may throw some certain exception, you have to either catch it by using a try and catch block, or you want to specify it. For specify, that simply means you don't want to handle the callee at this moment. You want to pass it through to the next one in the call stack, right? That's something we talked about before. I'm just mentioning that very quickly. All right, what I want to review will be about these 2, which will be very important. All right? Let's make the following assumption. If you take a look at these 2 lines of code, one is O.M over here, and O.M over here. Let's assume the following. This particular method M, let's say it's from some other class. This line may throw certain exception. Let's just say some exception. So we have the same line over here. As soon as you try to call this line of code in your own method, you have to be subject to the catch or specify requirements. In the case of the, let's talk about catch scenario. If you wrap around O.M inside the try and catch block over here, you can see some exception might be thrown from this line. And also some exception might be thrown from this line over here. And don't forget, in general, after this line of code, you might have more lines of code afterwards. Right? I'm just using ... here. But later on, we're going to see more concrete example very soon. Just bear with me. Let's talk a little bit more general principle, so you'll see lots of instances of that. And what you want to know is about these 2 distinctions. One would be called the normal flow of execution, meaning that if the exception did not occur. The second one would be called the abnormal flow of execution, which means the exception did occur. We're going to distinguish between these 2. All right, let's talk about it. Scenario number 1. let's say we go into the try block, we try to execute this line. Let's say the exception does not occur, in which case we're simply going to execute just the rest of the code over here. After that, we're going to bypass the catch block because no exception has been thrown, especially the some exception. It simply didn't occur. In that case, we're going to skip the catch block, and then we're going to execute the rest of the code beyond the try and catch block. Let me highlight it. So the execution path will be, we try to execute this line, and then execute the rest of the try block, skip the catch block, and execute the rest of the code beyond or outside the try and catch block. So that'll be scenario number 1. Are we okay with it? The main thing to notice is everything in the try block has been executed, and everything in the catch block has been bypassed because that exception did not occur. And then everything after or beyond the try and catch block, they are also executed. That's the normal flow of execution. And we'll see examples about this. Second scenario, abnormal. Let's say the exception does occur. Okay, let's see how the execution flow is going to happen, going to change. Let's say it does occur. We still try to execute this line over here, but this line here, let's say it throws that particular exception. That means we're going to bypass the rest of the try block because that exception has occurred, so we're going to disrupt the execution flow. And then because some exception is what we assume is going to be thrown, so we're going to go into catch block right away and then execute everything that's in that block. After everything in the catch block has been executed, we're going to go on to execute the rest of the code that's outside the try and catch block. Let's highlight the execution path. So you'll see, execute this one here. The exception occurs, so everything else will be disrupted. So we try to execute everything in the catch block to do something. And then we try to execute everything that's outside the try and catch block. All right, any question about the second scenario? They're definitely different, right? What you really need to know very well, especially as we go through many examples for today and possibly for Wednesday as well, also for other parts of the course. Every time, if the exception might thrown from the particular line, you want to think about 2 possible scenarios. Either it does occur or it does not occur. The execution flow will be just different. All right, any question before we see some example? Okay. Right, just keep this general principle in your mind, and then you'll find just easier to grasp the example that we're going to talk about. All right, let's talk about the circle. Okay, so we're going to revisit the circle example. And remember, the way we did error handling before is by doing system.out.println line, right? We talked about it. Let's now try to do something that's more appropriate, which is by using exception. And you also learned about last time how to create exception. I'm not going to bother you with that. Let's say we have an exception, invalid radius exception. By the way, so the name of the exception, in general, you can create any name you like, as long as the name of the exception does not clash with any existing library exception. But I would say in your lab and in your programming test, not for programming test 1, but maybe 2 and 3, the exception name will be quite restricted that you can use. It will be kind of specified by the JUnit test cases, all right? But beyond this course, you can create any exception as you wish. Right, so once we got this exception here, if we might throw it in some line, it will be subject to catch with specified requirements, all right? Let me just go directly to the code. Assuming that you're already familiar with the circle class, right? Let me just show you the addition over here. Let's start with the circle class, all right? If the radius, the parameter, is less than 0, rather than system.out.println line, right? So now we say throw new invalid radius exception. That's what we have done to replace it. And this method over here is already subject to the catch or specify requirements. But as we said before, the source where, the place where the exception was originated, usually you don't really do catch. You just do specify. I'll write it down just for one more time, just for clarity. So this is where the exception is originated. So this is where the exception is originated. I would say typically, at least for the context of this course, typically just do specify. Don't do catch. You don't want to catch it right away. It might be caught by the caller of this method. All right, that's one thing. And that's why we do specify here. You can see this would be the specify. Right? You can see it throws over here as part of the header of the method. That is specify. All right, so that's about the circle class. And of course, in the else branch, no exception. So you just set the radius to be r. All right. Let's take a look at the circle calculator. I say 1 here because I got another version for you, which would be more like an interesting case to deal with. Let's deal with a simple case. Let's say we try, different test cases. Let's say we try 10, and also we try -5, okay? 10 and -5. So you can see the execution flow. That's the main thing I want to show to you. And then I'll show you a little bit on the Eclipse as well. Scenario number 1, let's say 10. So this will be some valid input, so it's going to be the normal execution flow. So let's say we set this to be 10 to begin with, all right? And for now, I'm going to use the arrow to point out the execution flow, all right? We start with creating this circle over here. And when we go into the try block, we're going to set a radius to be 10. This one here, let's step into the set radius method, which will be over here, right? And we're gonna execute by checking this if condition. So this will be 10. 10 less than 0 will be false. So that means we're going to go to the else branch. And then we're going to execute. The radius is assigned to r, which would be 10. So that's why after that, no exception has been thrown, so we can go ahead and go to the next line and calculate the area. And then we're going to print out the area is this line over here. And that's it. And the catch block is not going to be executed because no exception has been thrown. Right? This is consistent with what we just talked about as normal flow. Right? Any question so far? And then I'm going to talk about something very fundamental, which you may have not noticed. I want you to look at this line, which is very important to remind yourself. Look at this line over here. The line I just highlighted in green, this line here happens immediately after this line, which might throw that invalid radius exception, right? You want to think to yourself, if the execution is such that I can reach this particular line, that means the exception has not occurred. Agree? Otherwise, you cannot reach there. Symmetrically, if I couldn't reach here to this line, which is right next to the line that might throw the exception, that would mean the exception did occur. All right, I'm going to write it down. These insights are so important. When we get to the more tricky and more advanced example, especially about testing, you will need that. Okay, I'm going to write it down. Okay, this line over here, just a highlight, okay? Reaching this line means the invalid radius exception occur. Number 1. Number 2, not reaching this line. I'm writing that explicitly, right, just to be sure. There are 2 cases. Not reaching this line means the invalid radius exception did not occur. Did not. Sorry, there's a not over here. All right, these 2 points are so important. All right, so what we just talked about is case number 1. It's a normal execution flow. Let's now try to do the abnormal execution flow. I'm going to use a different color for arrow, but just notice the difference. Okay? Let's say we try -5. Okay? So now if I do -5 over here, let me start from the beginning. Let's say we execute this line over here, create a circle, and we try to set the radius over here. And so that will be, in this case, -5. And then, in this case, we're going to step into the method, right? Set radius. So we go to set radius over here, and then we check to see. -5 less than 0. true. That means we're going to execute this line. And of course, we're going to bypass the else part for sure. And what's going to happen? If we say throw new invalid radius exception, that one there means this particular line at the end of it is actually going to throw the invalid radius exception. Are we going to reach this line at all? No, as we said before. The flow is going to be disrupted. What's going to happen is this particular exception will be caught just by this catch block, and then we're going to execute this line. All right? So that will be the flow. Right? You can see the same two blocks of code, and we just try different two test cases, and the execution flow will be just different. Marcus?
When you were writing down the two lines, you said that reaching the next line means that it did occur.
Aren't they the opposite?
Yeah, it's supposed to be the opposite. Just
Reaching, oh yeah, you're right, absolutely. Thank you so much. Maybe when I wrote, you didn't really represent what I meant. Thank you so much. Absolutely. I'm glad you pointed this out, otherwise people will be very confused. Thank you. Did not occur, absolutely. And the exception did occur. Okay, let's get very clear. Invalid radius exception occurred. All right. One is did not, the other one is occurred. All right, good. All right, guys, any question about the circled example? Let's now take a look quickly on Eclipse. Everything you will see on the Eclipse is going to confirm what I just said. Let's now go to Eclipse, and just remember the project has been made available to you. So under the exception circles and bank project, if you go under, sorry about the font size, I'll read it to you. Go to the package called the circles with exception, all right? And then if you go to circle calculator 1, go to that class. Okay? And so this one's slightly different from what you saw in the slides. I just made it a little bit more flexible. So we're going to read some input from the user, right? Let's try the 2. So I would suggest we put a breakpoint in line number 23 right before we try to set the radius over here. Okay? So what I would do is, let me check, 10 and minus 5. Let's try 10. Now, if I use a debugger, right? As soon as I launch the debugger, everything before is also going to be executed, right? So we're going to go directly to 23, right? So this is where the two scenario would differ, okay? Just hopefully you're following, okay? Let's try the debugger. And I'm going to launch the debugger. It didn't show anything. Okay, let me just try this. Maybe it didn't know which class I'm trying to run. Oh, actually it does know, sorry, just reacting slowly. Okay, first of all, let's try the first case, which would be 10. This will be normal, all right? Enter, and let's say switch. Okay, sorry, just a bit slow. Okay, there we go. So now we're in 23, all right? What we'll do, let's now step into this method, set radius, which means when I say step into, we're going to go into the circle class. If you click on step into, we are now in the circle class, right? And remember, the value for R is actually 10. If you move your mouse over here, it shows to you it's actually 10. Or you can look at under variables over here, okay? Now, 10 less than 0, we know that it's false. So if we say step over, it goes to the else part. No exception, right? Let's say step over once more. And we're going to go back to the caller, which would be, oh, sorry, that's the end. Let's go one more time, step over. All right, so what does that mean? You can see now we can reach the line right after this line over here. So that would suggest the exception did not occur, all right? And you can see now we are in the next line after that line that can throw the exception, but it did not throw it. So we're going to say step over, execute the rest, and question for you. I'm now in line number 25. After executing this line, Am I going to go to 29 or 32? Or both? It's an important question here. Marcus.
Be 32.
Why?
Because you haven't thrown an exception.
Yeah, since no catch block is basically useless at this point for this scenario. All right, guys, it's really important to kind of get used to this kind of mindset. Right? If you haven't just got 100% yet, that's okay. You want to study a bit on this. All right, let's say step over. Okay, just one more. And exactly right, 32. All right, that's case number one. Let's do case number two. Okay, let me go back to the circle calculator over here, which will be here. Yes. Let's now try to launch the debugger once more. All right, and this time let's try the invalid input. Let's say -5. Enter. Okay, we are now right before line number 23, right? Let's step into. If we step into, we're going to go to set radius. And this time, if you look at the value of r, it's -5. -5 less than 0 would be true. If you say step over again, now we're going to throw the exception. As soon as we execute this line, the rest of the current method is going to be bypassed. It's disrupted. All right, let's try that. Let's say step over. Right, so now we are back. Okay, Eclipse did many things in this case. Just remember what happened. In the circle over here, the exception was thrown. So the rest will just be bypassed. That means over here, in this particular method call that we just stepped into, that one there through the exception. So the rest of the block will just be bypassed. So we go directly to the matching catch. In that case, we're going to execute just this one here. Right? That's why it's showing that. It's showing 27. So we're going to say step over. Right? And question. After 29, what's going to happen? Are we going to execute 32, or we simply terminate the program? That's an important question. Anyone? Well, remember input are closed, like a line 32. Is pretty much like, let me draw some quick connection. If you remember what we said in the iPad, just in the very beginning, if you take a look here, if the exception has occurred, we execute whatever that's in catch block, whatever that's outside has nothing to do with the exception itself, so we still have to execute it. It's outside the catch block, right? Just remember. Let me go back there and confirm that. All right, if I say step over, so we'll still execute 32. So both cases will execute 32, all right? And that's something I would really recommend. You try to reproduce this kind of debugging yourself to really understand execution flow. I did both on the paper and the Eclipse, right? Any question about this? Don't lose the big picture. If you're calling a line that might throw an exception, you have to wrap it, let's say, within the try and catch block. In that case, you might have two possible scenarios, either normal versus abnormal. That's basically what we have said, right? And for the bank example, we're going to do something very similar. So for the bank example, I'll just do that on the paper. I'll leave that Eclipse part as exercise for you. If you're not too sure about how to do it, you can visit me, all right? We'll talk about it. Any question before I move on to the banks? Hopefully you guys are okay, right? It's only warm-up. We haven't talked about the actual challenge just yet. All right. All right, let's now move on. That's about a circle example. Oh, I think for the circle example, I got another nice addition for you. I'll show it to you. Right, circle calculator one, we just talked about it. You'll want to read the text in the slide as well. Okay, I want to give you a second version for the circle calculator. What we did so far, you can only set the input only once. If you set it to be -5, the whole thing will be thrown by exception and then just terminated, right? We want to make it more flexible to say, if the user enter -5, you allow them to enter another one. If they enter -10, allow them to enter another one until they enter something that's positive, right? We want to be more tolerant on our side. That's basically what we want to do. And something like this. You might tell the user enter radius, they give you -5. Apparently, -5 is going to trigger some exception internally in your program. But we somehow we're going to catch that exception so that the exception wouldn't be thrown to the console. And then we allow the user somehow to try again. So you might just need some kind of like a loop, all right? And then you're going to tell them, okay, what you entered was wrong, enter another one. And they enter another thing that's wrong. You just allow them to enter again. You keep letting them try until they enter something that's not negative. That's kind of the program we want to write, okay? And I'm going to go to the program right away. That will be one way to write it. And then I'll explain the main logic to you about that. I'll do some tracing together as well. But I would say for this one here, it does take some time, maybe for some of you to study deeper, right? I'm going to just go over that quickly, okay? But at least you should understand what we're trying to do here, all right? If I can just run that very quickly on Eclipse, that's for this one here, so you will see. If you go back to, let's say, Java perspective, if you go to circle calculator 2, all right, let me execute it. Enter radius -2. You can see the program has not terminated yet. -5, -20, you can keep going. Let's say, if I say 20 now, which is valid, it's going to calculate and then terminate, right? That's kind of the program we want to write. Simple one, but it does contain some valuable logic that we want to learn. Let's take a look at the program. All right, so we still got our invalid radius exception over here. The circle class has not changed, just the same as before, which might throw this exception here, and we specify it. What you want to look at would be this one here, okay? I'll give you 1 minute, okay? Take a look at the program, especially focus on what I highlighted in yellow. That's where the new addition, in some way, is, the critical one. Take a look for 1 minute, and I'll explain it. Okay, another 20 seconds or so, okay? And then we'll talk about it. All right, so hopefully everybody got a chance to read it. It's not too bad, okay? So what I'm doing here is I'm trying to use a Boolean flag or Boolean variable to control for how long I should really keep executing the while loop, okay? You might be thinking about, can I not use exit or continue keywords in Java? You may, and we wouldn't forbid it. However, I would say people actually tend to argue using exit or continue will have your code become the so-called spaghetti code, meaning that it's become too complicated to be managed in a large scale. So I would suggest you can definitely do this like a continue exit for your own project. But for this course, it will require you to understand this kind of logic by using Boolean variable. You kind of train your mind how things work. Okay, let's go over that, okay? So this Boolean variable here, look at its name. If the input radius that has been entered by the user is valid, then we'll say true. Initially, the user has not entered anything just yet, so we say it's false, okay? I'll write it down for you, okay? Let me use a different color. You can think about initially, no valid radius has been entered. That's why it's false. And if you look at a while loop over here, and look at the Boolean condition here. And from your first year, you know that for the while loop, in order to keep executing the body of the loop, you have to make sure this condition remains true. As soon as it turns false, you're going to exit from the loop, right? So what do we mean here? And I'm pretty sure you know what this means, right? Not, right? Negation. Input radius is valid, it's a Boolean variable. Whatever its value is, we're going to negate it. True to false, false to true. What does that mean? Think intuitively. We're saying that as long as it is not the case that the input that has been entered is valid, we're going to keep asking the user to enter another one. Otherwise, as soon as the input that has been entered by the user is valid, we're going to exit from the loop. That's how you can think of it. All right, I'm going to write it down. Here. Over here. As long as it is not the case. And not the case really is really denoted by the not over here. Not the case that the last user enter input is valid, keep executing body of the loop. All right, hopefully so far it's still manageable, right? And every time, if we are executing the body of the loop, what should we do? That means this should be some input to be read. Simply prompt the user for some radius and then read some value from the user, which may or may not be valid. And then we're going to create one circle here, and then we use this particular line here to help us decide whether or not the input is valid. How? Because we know this method here, setRadius, will throw exception if r is less than 0, right? So that means this. Okay, let me point out this line here. See the setRadius over here. Okay. This line here, 2 scenario. This will throw invalid radius exception if the radius is less than 0. Otherwise, if it is not negative, no invalid radius exception will be thrown. All right, that's this line here, right? And just remember what we said before. The fact that you can reach to the next line after that exception line. If we can reach the next line, that means the exception did not occur. And we're going to execute the rest of the try block and bypass the catch. The second scenario is if the exception did occur from this line. In that case, the rest of the line, the rest of the try block will be skipped, bypassed. And then we're going to go directly to the catch, in which case we're going to do something else. That's the overall structure. Okay? Let's now try to trace 2 inputs over here. One is going to illustrate the normal flow. The other one is going to illustrate the abnormal flow. Let's see. All right, I'm going to try -5 and also 10. Basically, expect this is what's going to happen. If you enter -5 the first time, we're not going to exit from the loop because -5 is not valid. In which case, we're going to prompt the user one more time for the input. And then once they enter 10 for the second time, we can properly set the radius and then execute, and then terminate normally. All right, let's try. Let's try by highlighting very carefully. Let's start from -5, all right? We're going to execute this one here, all right? Just initialize the scanner, and we're going to set the Boolean variable over here to be false. So let me put it here. So this will be input radius is valid, all right? Initially, it's simply false. I'll put F over here. Hopefully, it will be turned into true, T, at some point. And let's go to check the while loop over here, all right? We're going to decide whether we should enter the loop initially. Not the case, this Boolean value. Not the case, false, true. Agree? In which case, we're going to go into the loop for the first time. Intuitively, since the user has not really entered any value yet, so we're going to execute the body of the loop for at least once, all right? And then we're going to enter the loop for the first time. Prompt the user, so we're going to say, enter a radius. That's what you'll see in the console, okay? And then let's say we're going to enter for the first time. Let's say R will be -5. And then we're going to initialize the circle over here, go to try block, the first line, see the set radius, all right? This one here is going to execute the setRadius method over here. And then we're going to check the if condition. R in this case will be -5. -5 less than 0, true. We're going to throw this exception. All right? As soon as we try to do this, the rest of the method is going to be bypassed. Right? Just remember that. I'm going to just erase it for now to avoid confusion. All right, so we're going to throw this exception here. That means from here, the exception will be thrown. Invalid radius exception will be thrown. The rest of the try block will be bypassed. Agree? Okay, I'm just tell you. And then we're going to go for this catch block, which will catch that exception. Invalid radius exception here, and then we're going to execute this print. Try again. So that's why you will see try again. And so this will be the end of the while loop. So we are actually going to go back to the while loop once more. So far you can see the Boolean variable over here remains to be false. Agree? So that means we're still going to execute the while loop for another iteration at least. Are we okay so far for the first iteration? The first iteration allows us to really continue prompting the user for another input because the exception has been thrown. So you will properly do things. All right? So that's why you really got to go over the code also yourself. I'm going to trace one more iteration to make it complete. But I'll take questions for now. Yes? Yes, that's correct. That's where we left off. So we're going to continue from there. All right? So far, the program has not terminated just yet. Right? All right, let's now try the second iteration. And for that, let me use a slightly different color here. Let me use green. We're going to try 10. All right? So we check the while loop for second iteration. And at the moment, invalid radius is valid, still false. So not false will just be true. So we're going to execute the body of the loop one more time. So I'm going to prompt the user for enter radius. Enter a radius, second time. And let's say the user is going to enter 10 this time. All right? We still execute the next line to create a circle. And we go to the try block and execute the same line over here. C dot set radius over here. All right? So this time it's going to be 10. And we step into it, go to the set radius over here. So now what we got is we're going to execute the if branch over here. So 10 less than 0, false. No exception this time. That means we're going to bypass the if block, and then we're going to go to the else part and execute this. Set the radius to be 10. And we're going to go back to, so by the end of this method here, no exception has been thrown, right? So for the green one, no invalid radius exception thrown. Right? It's different. Notice the no here. So that means we're going to reach to the next line. We're going to set the Boolean flag over here to be true so that we don't need to execute the body of the loop one more time. And then we're going to system out the print line, system out the print line. We just say circle, with radius whatever. That's a calculation result. Going to execute the rest of the try block, and then we are going to bypass the catch block. We don't execute it because the exception was not thrown. And then that's it. All right? So 2 iterations over here illustrate 2 execution flow. Abnormal first, and then normal. All right? And, of course, this part over here is just the console output you will see. Okay? Guys, any question? I would say before Wednesday, for sure, study this example here, this new exercise, very carefully. When we get onto the next lecture about TDD, test-driven developments using involving exception, this kind of logic will appear over and over. So if you study this well before Wednesday, you definitely can get the most out of Wednesday. All right. Any question before I move on to the bank very quickly? Yes? Yeah.
like, read the input again and try to call the
Yeah.
set radius again.
For sure, for sure. The question, well, let me try to clarify. Okay, let me make it a little bit larger. Okay. Let's say the exception did occur. Okay. In that case, we're going to print out some error to say try again. So now it's kind of up to your implementation. For my implementation, I don't really do anything too complicated in the catch block. So, but let's see what's going to happen. Let me review it. Okay. Let's say after the exception has occurred, we tell the user try again. Don't forget, this try block over here is in the context of this while loop. So after executing the try and catch block, you're still going to go back to the while loop header to see if another iteration will be necessary. So let's say after this one's done, you're going to go back to the beginning of the while loop over here. That one there is going to check this Boolean condition once more. And remember, after the first iteration, it remains to be false. So not false will still be true. So that means we're still going to execute the body of the loop, the same one, once more. And that one there, indeed, is going to prompt the user for another radius. That's how the logic works. But of course, you can try, in your case, try to do something maybe more sophisticated in the catch block. It might still work. It might. I'll leave that to you as exercise. Okay. All right, guys, any more questions? Yeah, I spent more time on the circle example because in some way that's not so, we don't really have a call stack just yet. So I think we can do a little bit more emphasis on what's happening here. But I think for the bank example, I'll point out to you where you should really watch out for, and I'll leave the tracing to you, some part. All right. All right, let's now do the bank example. All right. Let me see anything else I need to say on the slides. Yeah, the same code over here. And if you look at, when you look at the slides over here, when I talk about a line number here, so these are just the execution flow. You will see they will just correspond to what I said on the iPad. And a very typical written test question I might ask in the next one, maybe. I'll give you a block of code involving some exception, and then I would say, let's say given this particular input, now highlight the lines for the execution flow, which I did, what I have done many times so far. Right? But I'll try to give you guys some practice question, maybe before that. But just remember, you want to understand the principle very well. All right, let's talk about the bank example very quickly. And similarly, we also create another exception called invalid transaction exception. Pretty much like an invalid radius exception, similar. Okay? The same logic as before, and let's now take a look. Okay, I'll just go right to the point. And then we'll try to trace one code, just one line. Oh, sorry, one input. Let me remind you very quickly. We have invalid transaction exception here. We got the account, we got a bank, we got a bank application. We talked about a call stack earlier, right? Maybe last Monday or Wednesday, I forgot. Anyway, so it's something we talk about. You can review the lecture if you're worried about if you're not sure about the call stack. For the account, we got, let's say we focus on the withdrawal method, right? So we say that if the amount you want to withdraw is negative, or it simply don't have enough balance for you to withdraw, it's going to be considered as an error. In which case, we're going to throw new invalid transaction exception, right? So this is the source of the exception, which means we don't really do catch in this first level. So we just do specify. All right, so this one over here is specify. All right. And if you go to the bank class, you can see this line over here might throw that particular exception, right? Let me highlight it. Okay, let me use a different color here. This line over here. Right, so this is the line. You can see we are calling the withdrawal method from the account class, right? So this line over here may throw the invalid transaction exception. All right, so that's why it will be subject to catch or specify option or requirements. In this case, we simply do specify. All right, so let me highlight it. Let me just write it down. So this one also here is specify. And you can see, you want to think a little bit more abstractly here. What we're doing here is like a version number 2 in the to handle or not to handle example, right? We are leaving the last level to handle the exception. All right, version number 2. And let's now take a look at bank application. here, you can see here, this line, b.withdraw, right? Because if you look at this line, withdraw method here, specify that it might throw the exception. So that's why its caller over here has to be subject to catch will specify requirements, right? So I'm going to write it down here. So this one here may throw the invalid transaction exception. All right? Are we okay so far? Right? Of course, this would be very similar to what we did before when we only got a console, like an error message. But now we got the exception involved, so that's why the catch will specify requirements has to be obeyed at every level. All right. Okay, let's do one input over here, just one. And I just drew the diagram over here just in case you're worried about what's kind of the runtime structure, right? We got a bank, we got an array of accounts, and number of account is simply just one. Let's say we got one account with the ID 23. That's basically what we're doing. So if you look at the line here, withdraw 23, we're basically trying to withdraw some amount of money from over here. Let's say current balance is 0 or something else, right? That's what we're doing. The test case will illustrate some abnormal execution flow. Let's say we want to withdraw minus 5 million from the account, right? Of course, it should be disallowed. Agree? Good. Let's now see that. Let's now highlight the execution flow, line by line. This one here creates the bank. This one here creates the account. This one here, add the account. Basically, after these 3 lines, you got exactly this runtime structure, right? That one is basically what you study for your written test 1. So if you got trouble, reach out to me. And we're going to initialize the scanner and also read some input from the user. Let's say the user enter minus 5 million, all right? And go into try block, and we execute this line, withdraw. That one there, so this amount will be minus 5 million. So let's say we step into the withdraw method, which would be over here. And we try to execute a for loop, and you can see at the moment, the array only stored just one account. So we'll get that in the first iteration, right? That's kind of simple case. And we're going to execute this one here. If accounts ID is equal to ID, because remember we're trying to withdraw 23, and the one we're looking at will be 23, so they're matching. So now we're going to do the withdrawal. And we're going to execute this line over here. And this line here is actually going to involve the withdrawal method from the account class. So let's step into one level down, right? So we're going to go to the withdrawal method in the account class over here. And don't forget the amount was minus 5 million. So it's going to be minus 5 million. Apparently, minus 5 million less than 0. True. And if that's true, the OR is going to give you true overall, right? So that means we're going to throw this exception. If this exception is thrown, what's going to happen? Let's think about it. Of course, the rest of the else will be just bypassed. So that will put a cross over there. So we're saying that this particular line over here, in this case, will throw that invalid transaction exception, right? And since this particular method here only specifies it, so it's not going to handle that. So this exception will just be propagated to the next level. So that would mean this particular line over here is going to throw that invalid transaction exception, this line. And this is where we're going to handle the exception by using try and catch block. And since the exception occurred, we're going to bypass whatever that's rest for the try block. And then we're going to go to the catch block over here, which will match that particular exception. And then we can execute this line. So this is something typical people like to do. If you say system.out.print line, if you just print out the exception object itself, it's going to give you more information about the exception, like where it is from, and et cetera. All right? All right, so that's the execution flow for this. exercise for you. What I just traced was the abnormal scenario. Try some valid input. Let's say 20. Let's say we want to withdraw 20 from the user. Let's say they do have some money there for you to withdraw 20. What's going to happen for the execution flow? And when you do this, I will highly encourage you to try, number one, on the paper, for sure, to start with. Number two, on the Eclipse. We show you already how to do it, right? That'll be the best way to really understand what's going on. Any question so far? If you're up to now, if you're following about 50%, 60%, I would say that's pretty good. So don't feel bad if that's not 100. You just need time to think about. It's not easy. All right? Any question? Okay, why don't we take a mini break by taking attendance to give you guys some reward. All right? Why don't we do that? Bear with me. I need to just refresh my location. We got two more examples to talk about for the exception, and then we can move on to the next lecture. Okay. We'll see how far we can go today. Bear with me for about 30 seconds or so. I need to refresh my location. Okay. Let me go to the course. Yeah, meanwhile, feel free to stretch your legs and take a very short break. Right? And we're going to talk about more. If I go to settings, and then I will go to attendance, don't require, allow to refresh, and save. And we now should be ready. All right, there we go. Start the class. And then the poll. There we go. Okay. Yep. Check in, please. If you got trouble, raise your hand right away. All right. One, I see one here. Maybe take some time to refresh. Still not working? You know, if it's still not working, just come over to the front. Right? Just come over. I want you to write down your name, and then that'll be okay. Just come. Anyone else got trouble? Come to the front, please, right away. Yeah. Why don't you find your name and then sign? Yeah. Okay. If nobody else got trouble, okay, I'm going to end the poll very soon. Thank you. Thank you. You want to come over right now? Let's not waste time, please. You work now? Okay. Thank you. Do it now, please. Okay, can I end the poll? All right. There we go. Thank you so much. Thank you. Awesome. Okay, one more minute. Take a break, just one more minute, and then we can continue. Hopefully, exception is not too bad, right? Hopefully. If that's your first encounter, it's kind of confusing, I know. Take some time. In some way, inheritance would be, if not equally challenging, I think it's more challenging than exception. But in some way, inheritance would be more fun to study. It's actually much more realistic to think about. But we'll get to shortly after the reading week for inheritance. All right, let's resume. All right. I got two more examples to show you about the exception lecture. Let's do them one by one. The first one is something I mentioned last time, but I didn't really exemplify it. If you have a fragment of code inside a try and catch block, in the try block, So far we saw there's only one possible exception that might be thrown, either invalid radius or invalid transaction. But in general, there could be more than one exception that could be thrown from the try block. Let's take a look. Just a simple example. If you take a look, just this try block over here, see what we're doing here. You know what? Might be easier if I just go directly to here. I want you to focus on, first of all, this line. Sorry, this fragment. This is the fragment of code that's really wrapped around by the try block. What you want to notice is more than one exceptions might be thrown. I'm not saying it will be, but it may be. But we're going to see. More specifically, this line here is going to withdraw some money from the bank. And this line over here is going to set the radius of some circle. For some reason, you want to put circle and bank together, let's say. Right? I'm not sure why, but let's say for some reason you want to. So to deal with this particular block, you have to make sure you have the corresponding catch block just in case those exceptions occur. So you can try the following. If you simply eliminate this particular catch block, let's say, if you do it in Eclipse, it's going to give you error, saying that this particular exception over here is not really handled. Okay, I'm going to write it down, and then you should really try on the Eclipse. This is some side note. Removing this block causes error because this particular exception here will not be handled. The negative radius exception not handled. Okay, give it a try. If you put this into Eclipse and just get rid of this block, symmetrically, if you leave this block over here by get rid of this block, it's going to complain this particular exception is not handled symmetrically, right? You want to make sure every possible exception that might be thrown from the try block is somehow handled in a catch block. That's the principle, all right? Let's now try to trace the code, all right? Let's try test case number 1. In this case, we give some invalid input for the withdrawal, but we give a valid input for set radius. That's case number 1. Case number 2, flip it. We give a valid input for the amount, but we give an invalid radius over here. Let's see what's going to happen, all right? And always don't forget, when we execute the code, it's going to be from top to bottom, all right? Let's try. The first one. Let's say test case number 1. Right? I'm going to use orange. Create a bank, create the account. Oh, sorry. Let me do it again. Create a bank, add the account. You can see I'm using the anonymous object over here, right? We reviewed that before. Just don't throw it away. Also, you try to deposit over here. And over here, let's say for the, also we try to do withdrawal. Let's say for the withdrawal, we simply try minus 5 million. We know before it's going to throw some exception. Agree? So we can expect that at this point, it's going to throw invalid transaction exception. Are we still going to create a circle in the next line? No, because it will be disrupted, right? So that means after this, we're going to just go to the invalid transaction exception. And then we're going to execute those 2 lines. That's scenario number 1. Notice that we don't even get a chance to enter 23 because this block of code here happened after the exception is thrown. So you'll be disrupted. You never get there. Are we okay with this? First scenario, first test case. The second one, let me use maybe, how about purple? Okay. We're going to enter some valid input for the amount for withdrawal, but some invalid input for radius. Okay, let's try. So we still create a bank, we still add an account, we still try to deposit, and we try to withdraw. In this case, we try to withdraw 100. In this case, it would be valid. Okay, that means the purple one, it does not throw. The invalid transaction exception. That means we're going to reach to the next line, right? Reach the next line, create a circle, and now we try to set the radius. And the radius we want to set will be -5. And this one here is going to throw some exception, agree? -5, right? So this line over here, this call, is going to throw invalid radius exception. And are we still going to go to the next line in this case? No, it will be disrupted, right? So that means we're going to go to this catch block, which will catch the negative radius exception. And then we're going to execute this line and this line. Are we going to execute this catch block in this case? No, because only this exception was thrown. So you don't really go to any other irrelevant catch block, and that's it. Right, what's the point of this example here? Number one, in a single try block, you might have lines of code that might throw multiple exceptions. Number two, to make the code compile, you need to have one catch block for each individual line that might throw the exception. Number three, when you actually have at the runtime got different input values, you want to know exactly where the exception might occur if you have it at all. And the execution flow is going to depend. It's going to differ. All right? All right, that's one example here. Any question? A very small side note over here. In this case, this exception here and this exception here, they have nothing to do with each other. So make it a bit simpler. Later on, let's see if we have time. After we have covered the topic of inheritance, it's going to be more interesting because the order in which you put the exception classes over here, if those classes are somehow related by inheritance, you got to be careful. But I just want to put a side note. For now, you're okay. You don't need to worry about them. But later on, if we get to the inheritance, if we have time, I can add another example just to show to you. That'll be the much more general case to handle. All right, last example, last one. Okay, so this one, I think some of you actually asked me last time, just about, oh, what if, let's say I'm expecting some integer for my input, but I enter some string. How can I allow the user to actually enter the input again? I think some of you asked me last time. I forgot who. Anyway, so this is your answer. Okay? Let's now take a look at what we expect to do, and then you will find that the solution to this is something we have gone through already. All right, let's take a look. For your information, so there is a class called integer in Java API. Okay? They have a static method. If you recall what static method is, that means you can call the method without creating a context object of type integer. You can simply say integer.parseInt, right? Some string over here. All right, so you can see this is specify option. This is telling you that by calling this method here, it may or may not throw this particular exception. Okay? And for example, let's say this. If I say integer.parseInt, if I give a string quote, right? If I simply put 23 over here, what the method tries to do is to take that string verbatim and see if you can convert it into an integer. In this case, 23, 2, and 3, yes. So that will return 23. That's like a normal scenario. What if I do 23 spelled out, right? Just anything that cannot be converted directly. In that case, it's going to throw that number format exception, which is specified, right, over here. All right, so these are the two scenarios for calling that method, all right? Now here is my question for you, or a little exercise. We want you to write a fragment of code that simply allows the user to enter string, pretty much like for them to enter radius, right? As long as they enter something that cannot be converted into an integer, you'll keep prompting them, give them a second chance. until they give you some string that can be converted into integer, right? Similar logic, right? It's a radius example. Circle calculator too. And do we have any, well, okay, that's a solution, all right? Guys, do you have any idea how to do this? Yeah, before I point to Marcus, let me just give everybody a hint, so at least you can think about it. I'm pretty sure Marcus knows this correct solution. In order to do this, you want to take advantage of the fact that the method itself, throwing or not throwing the exception, tells you whether or not the input was valid. To really see that normal versus abnormal execution flow, you have to use a try and catch block. And then whether the line after the method that might throw the exception can be reached will tell you whether that exception actually has occurred, right? Everything we have said so far is like a simple application. Marcus, tell us your thought.
Well, I just started writing, but basically it's going to be like that other example that you
Yeah.
showed. So you're going to have a Boolean that I set to false.
Yes.
And then you have a while loop
Yes,
with exclamation point before the variable.
yes.
So it keeps running.
Mhm.
You're going to prompt to enter a number as a string.
Yes,
And then after that, you're going to do a try and catch to see if it will throw the exception.
absolutely.
If it doesn't throw the exception, then you change the value of the Boolean so
Yes.
that it kicks you out of the while loop.
That's absolutely brilliant. Thank you so much. That's exactly right. All right? Let's now go over that solution very quickly, right? It's basically just another instantiation of the pattern that we saw for the circle calculator too. Let's take a look. Okay? Okay. Well, exactly what Marcus said. All right? Let's take a look. We have this Boolean variable over here, initially false. As long as the user has not entered something that's valid, we're going to keep executing the loop. We got a try and catch block over here. If we are able to reach the next line, which goes after this particular line, which might throw, you know what, let me just use a different color. I want to reserve the green. We know that this parse int call over here may throw number format exception. Okay? If we are able to reach the next line, that means the exception has not been thrown, meaning that the user input must be valid, in which case valid integer should be set to true. In which case, when we go back to the loop, checking this condition again, not true is going to be false. So we exit from the loop. We are done. On the other hand, if the exception has been thrown from here, we're going to bypass the rest of the try block and go to the catch block over here, which will catch the number format exception. And then we're going to do something over here to tell the user, OK, try again. You enter something that's not right. All right, why don't we try to trace very quickly as a final reminder. Okay. Let's say the user tried to enter 23 to begin with. So what's going to happen is we set a Boolean valid integer over here, initially false. While loop, so not false, is going to be true. And we're going to go into the loop, execute the first line, enter an integer. And the user is going to be prompted for some string. Let's say for the first time, it's going to enter 23. 23. And then we're going to try this. And integer the parse int. This one here is going to be 23, right? And according to the behavior, API for the method, this one here is going to throw. Throws number format exception. That means we're going to bypass the rest of the try block, and we'll go directly to the catch block over here. And then tell the user, this is not a valid integer. Okay? Oh, the user entered 23. I'll just write it here. 23. And then, of course, we're going to tell the user it is not valid. Okay? And they will be able to try again. How? Because after this catch block, we are reaching the end of the while loop. So we're going to go back to the header of the while loop and check once more this condition here. That one there, not the Boolean flag, which remain to be false, will be true. So go there for one more time. Let's now use a different color here. Let's say 23. All right? So we're going to execute we check this and then execute this. So enter an integer the second time. Enter an integer. And let's say this time the user enter, let's say 23. Okay, they enter 23 over here. And then we're going to go to the try block and user integer, sorry, just calling this same method here, right? So the user input here will be 23. In this case, it can be converted into the integer value 23. That means the number format exception was not thrown, which is awesome, in which case we're going to reach the next line, which is going to set a valid integer over here, Boolean flag, to be true. And then we're going to bypass the rest of the catch block. And then we go back to the beginning of the while loop over here. In that case, not true, false, exit from the loop. We're done. The same logic here, all right? This code was not really made available as a source code, so I would suggest type it out in Eclipse and try to trace it using debugger. That will be another nice exercise you can do, okay? Exercise. Okay, so type and debug in Eclipse. All right. That'll be the final example for exception. Any question? But we're going to see exception actually in the next lecture almost right away. But any question here? Are we okay? Okay, let me just see. Beyond this lecture, I do have some recommended stuff. You can take a look. Right? You want to maybe, basically make sure you can create exception classes, for the circle and for the bank. And also, these are the two source code I made available to you. Take a look at them, play with them, make some modification, and see how things work. And specifically, you want to understand normal versus abnormal execution path or flows. So these are the key takeaway for today. Any question? I think we got about 6 minutes or so. I would suggest we do something very light to set the ground for Wednesday. Okay? So we can move on now to the next lecture, which would be about test-driven developments and also with JUnits. And we're going to see, especially, well, you already learned about JUnits in your Lab 0. Well, I want to develop more into it about how you can test with exceptions. That'll be the fun part, all right? But we'll do most of the technical stuff on Wednesday. For now, I want to set the ground, okay, as much as possible. I'll let you go in time, so don't worry. Okay, learning outcomes here. So we want to learn about testing given some method as your programming solution. You want to test whether or not it works. And the solution we are choosing is something very simple, bounded counter. Remember the following. The counter is going to have only values from 0 to 3, either 0 or 1 or 2 or 3. If you want to decrement the counter from 0 to -1, exception. If you want to increment the counter from 3 to 4, exception. That's simple, all right? I'm going to keep emphasizing that. That will be the working example we need to have. And what we'll start with, pretty much like how we introduce exception. Before we introduce JUnits, we want to show to you what if you only got console messages at hand. You can still do some testing, but it's very error-prone and inconvenient. We'll do that first, and then we'll see how to convert them into the corresponding JUnit tests. And how you can, this will be a little bit like an extra. I want to show you how you can derive test cases on your own. Okay, I'll do that next time. And also how we can do JUnit testing. That's something we'll do as well. And the final topic for maybe Wednesday, I'm hoping I can get there, is called something called regression testing. Okay, that's something I want to talk about as well. It will be very nice practice for you to adopt. All right, let's now set the ground. I got about 4 minutes. Okay. We're going to consider a counter whose value can either be 0, 1, 2, or 3. Cannot be -1, cannot be 4. So we got two kinds of exception over here. Okay? One is called value too large exception. The other one is called value too small exception. Right? They suggest very well by their names. We'll see how to use them in just a moment. So if you ever try to throw any one of these exceptions, of course, you're going to be subject to catch or specify requirements, right? Let me just talk about that one there very quickly, okay? And then we're done. Okay? Okay, just make sure. Okay, we're good. Right, we're assuming that we actually got two exceptions. We got value too small, and also we got value too big exception, okay? So now let's say this. If I have some method M1 over here, and that one there throw this particular exception, this is where the exception is originated, right? So that means we only try to specify it, okay? Specify in where the exception is originated. And another context where you can specify would be, let's say in under C2 and 2, all right? Under C2 and 2, the caller. We are trying to call C1 and 1. And we know that according to the header of M1, if you take a look at here, for M1, as part of its header, it might throw value too small exception. May throw value too small exception. In this case, we choose to specify, which is valid. Okay, so far it's more like a review. The top one here is about where the exception was originated. We usually just do specify. Another one is when you are calling a method that might throw some exception, you can also choose to specify it. That would be option number 1. The second one here would be to catch it, okay? Let's say we're still calling this C2 M2 over here, which may throw some exception. Let me just take a look. Okay, so this one here may throw the value too small exception. And in this case, let's say we don't want to specify. We want to handle that. And the way to do it would be we simply wrap it around in the try and catch block over here. Right? So this will be the catch option, which is still satisfying the catch was specified. One more thing to point out. As soon as you do the catch option for this particular caller, you do not really want to do also specify over here. If you do it, it's going to be an error. Let me write it down. Okay. If you actually try to say throws over here, value too small exception. So this would be an error because the exception is already handled. You cannot do both. Okay, let me just write it more properly. All right, so that's what I want to go up to. On Wednesday, we'll try to move as much as we can for this lecture here. Do you guys have any questions about exceptions in general? You okay? Yeah, try your best to really review what we have said today before Wednesday. Otherwise, you might just feel quite lost in the beginning. All right, we're going to talk about some more advanced stuff about using exceptions. All right, thank you guys. I will see you tomorrow for your programming test 1. All right.